Hey guys, welcome back. Today we're going to do our final lesson of the year here. And it's just going to be a couple of problems, or a few problems from two sections, 10.3.2 and 10.3.3. And so a couple of problems in 10.3.2 are basically going to involve parabolas and lines and how they are related. Basically either within a system or just when graphed together. So we're going to look at points of intersections in particular. Okay, so 10.3.2, we're going to look at how many points of intersections there are. So starting with 10-21, let's read this. It says, as you have seen, sometimes a parabola and a line never intersect. However, if a parabola and a line do intersect, how many different intersection points can they have? How many intersections can two parabolas have? Do two parabolas always intersect? On graph paper, sketch a graph that fits each description below. Not every graph is possible. As you graph, consider the questions above. So I want you guys to just pause, take a moment here, and sketch each one of these 7 situations, A through G. And you don't have to use graph paper. It could be a pretty sloppy sketch. But just see what you come up with. For example, for A, graph a line and a parabola that intersect twice. Right? So just do a simple sketch with that. You don't even need your X and Y axes for this. So again, pause the video and come back when you have this solutions to all of these. Alright, so we're just going to do these. Going to go along here and just give you a quick sketch. So for problem A, a line and a parabola that intersect twice. Well, that's pretty straightforward. I have a parabola and I have a line, intersects twice. Pretty simple. For B, it says a line and a parabola that intersect only once. I can just sketch a parabola and then a line that goes through maybe the vertex or just a part that's tangential to the parabola. Okay. For part C, a line and a parabola that intersects more than twice. Well, if I have a line and a parabola, there's no way it's going to intersect more than twice, right? It's just 2 times is going to be the maximum at those 2 points. For question D, it says 2 parabolas that intersect twice. Well, there's 1 parabola, there's 2 parabolas, right? I've got 2 points of intersection right there. So it doesn't even have to be one parabola opening up, one opening down. You could have 2 opening up. So you can have a parabola that's like this, right? And then the same upside down, both of them opening down. For part E, 2 parabolas that have an infinite number of intersections. No problem. If I have a parabola like that, and then I have another parabola right above it, like that. Basically, it's 2 exact same parabolas. They have infinite solutions, infinite number of intersections. Okay, 2 parabolas that never intersect. Easy peasy. There's one, there's another one. They're never going to touch. And then 2 parabolas that intersect only once. Could be like this. Intersects only once. Okay. Alright, we're going to go over to 10-22 here. And when given a parabola of when given a graph of 2 parabolas or a line and a parabola, it is usually easy to determine how many points of intersection they have. But how can you tell algebraically? So basically, it says that each team is going to be assigned one of the systems below. It's just asking you to solve this using the algebraic method of your choice. Don't use a calculator because it says no calculator. And it says examine your algebraic solution to decide what it indicates about the graph of the system. That is, do the parabolas intersect once? Do they never intersect? Once you have solved your team system, have your teacher come up to you guys. That's obviously not going to happen. Or you can use a graphing calculator to check your answer. So go ahead and get on Desmos to check your solutions. And if you have time, you're obviously not going to do a poster, so not a big deal. Okay, so even though it says you guys are going to be do only one per group, why don't we choose 2? Okay, any 2 that you want from this screen, and see what you guys come up with. I want you guys to solve it and see how many solutions you guys have. Okay, so A, B, C, D, E, or F, just pick 2, and I'll share the solutions with you afterwards. Okay, so pause this video for as long as you need and come back to check your answers. Okay, so for the sake of time here, I'm just giving you the solutions for this problem. So no matter which ones you did, whichever 2 you chose, or maybe you did all 6 of them, there are your answers for those problems. If you guys have questions about this, ask me during our Google Meets, and I will go over this. I will gladly go over any questions you may have for this problem. All right, we're gonna skip on over to 10.3.3 now. That wraps it up for 10.3.2. Alright, so for 10.3.3 we are solving quadratic and absolute value inequalities. And basically we've gone over a lot of this before, so it's just kind of review for you guys here. We're only going to do 3 problems from this lesson, and we're going to start out with 10-132. And it says, now consider the inequality, the absolute value of x minus 2 is greater than 3. We're going to try and solve this. I want you guys to do this. I want you guys to try and solve this problem. And think about it as, if you recall, when we did this type of equation, right? When we have absolute value equations, you're asking yourselves, well, what is a solution for x that will give me an answer that is 3 spaces away from 0? Right? So there's going to be 2 possible answers for this. So again, you're going to apply that same type of thinking for this. I can't remember if I've gone over something similar to this with you guys in the past, but try your best, and if you're not sure how to do it, just continue with the video. But right now I'm going to go ahead and take a quick pause. Alright, so to solve this problem, you got to go back and think about how we solved this problem in the past, right? When we solved that problem, because we're asking ourselves what are the solutions for x that will make this true, where you'll give me an answer that is 3 spaces away from 0. Well, what is 3 spaces away from 0? It's a positive 3 and it's a negative 3, right? So you're asking yourself, what is x minus 2 equals 3, and what is x minus 2 equals a negative 3? Right, let me give myself some space here. So you're solving it 2 times. Okay? One is to the positive version, one is to the negative version. Now, same deal when we go over inequality, absolute value. Right? You're asking yourself, what are my solutions that will make this true, where x is going to be, or the solution is going to be greater than 3. So I want greater than 3. What is x minus 2 greater than 3? If I were to solve that, I would have to add 2, and I'd say x has to be greater than 5. So any number bigger than 5 will make this true, will make this inequality true. Any number bigger than 5, right? So the confusing part is, well, it's not really that confusing, but when we change it to a negative 3, we actually have to switch the inequality here from greater than to less than. So we also have to ask ourselves, x minus 2 is less than 3. Well, what's my solution there? Well, it's going to be x is less than a negative 1, right? Because you're saying if x is greater than 5, anything bigger than 5 is going to be a part of your solution. Well, if we didn't change this right equation, and we set x is greater than negative 1, well, negative 1 is not greater than 5, so there's no way that this would work, right? So we got to So when we're solving absolute value, we got to switch the inequality. So this is technically, we got two boundary points, right? We have x is bigger than 5 and x is less than a negative 1. So when we graph x is less than 5, or excuse me, x is greater than 5, on a number line, there is 5, and we would say greater, right? And then for the other one, we have to say x is less than negative 1. Well, there's negative 1, and then we say less than. Right, so because there's two boundary points, you can actually put this on the same graph. And if I'm not mistaken, we've talked about this in the past. There's negative 1, there's a positive 5. So x is greater than 5, x is less than a negative 1. This is what we call a compound inequality. There's two different solutions that will still make this true. Okay. All right, so I'm not going to answer question B for this problem. How was solving it differently than solving a regular inequality, because pretty much self-explanatory there. All right, so the next problem we're going to do is we're going to skip 10-133 and jump straight into 10-134. Okay, and I want you guys to take a few minutes here and just solve all 6 of these inequalities. All right, so take as much time as you need. This is great practice for you guys. Remember, you have your test coming up very soon. Just do all 6 of these and then check your answers when you're done. Just pause the video and come right back. By the way, there is a small typo error here on problem E. The negative 2 with that absolute value bar right next to it, that shouldn't even be there. Right, so ignore that, pretend it's not even there. I don't know, CPM dropped the ball on that problem. Okay, so hopefully you have finished all of these, and I'm going to show you the answers now. All right, for the sake of time, I'm not going to go through every single one of them, but I will display the answers for you guys. Hold on one second. All right, and there are your 6 solutions for 10-134. And again, if you have questions, you'd like me to go over any one of them in detail, I will be more than happy to do so. Just contact me or join our Google Meets, and we'll go over them. And so we're going to leave you guys with one last problem today. And this last problem is something that you guys have actually taken a look at in 10.2.3. So I want you guys to attempt to solve that. There's actually a few different solutions that you can come up with. Okay. So once you are done, pause the video once you're done, come back and check your answer. Alright, and there you have it. You have your 4 different answers here, and those boxes down below. Really, the way I started this is obviously I'm going to have to get rid of that 4 first by subtracting 4 on both sides, and then I'm going to get 16. 20 minus 4 is 16. To get rid of the second power on my left, I have to square root it. It's the inverse of squaring a number. So I've got the square root on my right side. So the square root of 16 is a positive and a negative 4. Right? So I'm now at that stage. And because I have a positive equals a positive 4 and a negative 4, that's why I rewrote it 2 times there. Okay. And then after I rewrote it 2 times, my first step is going to be the same by by adding 6. Get rid of that negative 6 on both sides. And so I'll have equal to 10 on the left, and I'll have it equal to 2 on the right. And then to get rid of that square root here, that right there, I'll have to square it. Again, the inverse opposite of square rooting a number is squaring a number. So I'm going to square both sides, and then 10 squared is 100 on the equation on my right. I do 2 squared, which is 4. And so that gets rid of that radical, and now I have the absolute value of x plus 5. On my left side, I have an absolute value of x plus 5 equals 100. Because it's an absolute value equation, I set it equal to 100, and I set it equal to a negative 100. So there are 2 numbers that are 100 spaces from 0. And then on my right side, do x plus 5 equals a positive 4, and x plus 5 equals a negative 4, and the rest should be history. All right. that's it for today, guys. It's our final lesson. You guys have a test coming up. I'm going to post the homework. And if you have any questions, please let me know. I'd love to hear from you guys. Hope you guys are doing well, and I will talk to you guys hopefully sooner than later. Have a good one, guys.